so this is 207. So our first step is to factor and cancel if we can. And I showed you yesterday that the kind of cheater way to factor, if you think there could be a hole, is, all right, if there's an x minus 3 on the top, I'm going to look for an x minus 3 on the bottom when I'm factoring, right? So this is the second page of 207. How does that denominator factor? So what are the factors of -6 that add up to -1? Now I want to factor that denominator. There is an x minus 3. So it's x minus 3 times what? X plus 2, right? X times x is x squared. -3 times 2 is -6. And then your outer plus your inner is 2x minus 3x is your -x. So your factor is allowed to cancel because it's identical. And then when you cancel, make sure that you leave a 1 because anything divided by itself is 1. So this is what we referred to yesterday as our new function. So if you started finding your y-intercept and x-intercept from this original function without canceling first, some of these answers are going to be incorrect. So you want to jump over and answer the questions from this new function. So how do I find my y-intercept? I plug in 0 for x, so what would I get? Why don't you guys try A, B, C, D from your note card? And then maybe we need to review how to do the whole part. So take just a minute, see if you can answer the first 4 steps from your note card. Good morning. Okay. All right, so I'm going to graph all that stuff, right? So my y-intercept is at 0, 1/2. So 0, 1/2 is here. I have no x-intercept. I have a vertical asymptote at -2. So to me, this is a pretty fair game question for tomorrow. There's one vertical asymptote, 2 sections of graph that are not, tricky. So y equals 0 is your horizontal. And so we know that the elbow goes through this top right region up here. Oops, sorry, you can't see what I'm doing. Top right region, elbow. And then I need to figure out where my other elbow is. Is it going to be like a volcano or is it going to be opposite? And I should plug in, let's see, this is at -2, so I should plug in -3 into the original, or sorry, into the new function. So if I plug in -3 up here, I would get -1 in the denominator. So 1 divided by -1 is -1. So at -3, I'm at -1. So there's my other elbow. So this is a pretty, I would consider it a relatively easy rational function to graph. We didn't have to do any crazy division. There was only a couple points to find, and the whole was relatively easy to do without a calculator. Plug in 3, 1/5. So 3, 1/5, 1, 2, 3. You just kind of put an open circle on your graph to show that there's a hole there. And tomorrow it's with a note card, so you could do those steps with a note card. The only new piece is the canceling piece that we talked about yesterday. So how do I define the domain and range? I'm not going to have you do that on the quiz tomorrow, but on your test, I'm going to ask you about the domain and range. And a hole affects the domain. So I have 2 undefined values, one at the asymptote and one at the hole. So x cannot be -2 or +3. Because a hole, I also have to lift up my pencil, and I don't have anything at that point. My range also gets affected by holes. So as I scan from top to bottom, my graph gets interrupted at 0 and also at 1/5. So don't forget a hole when you're stating your domain and range. Asymptotes and holes affect the domain and range. So do you think you could do a problem like that? Tonight on the homework, you'll get some more practice too. So, all right, I want to do number 2 together because something kind of funky happens with this one as well. So why don't you factor and cancel? So do the first step, but then as soon as you do the first step, it kind of changes the rest of the problem. So take a minute and try to factor and cancel that. So it should factor into difference of squares, right? X minus 2, x plus 2. Well, when your x minus 2's cancel, you really no longer have a rational function. You really have the linear function x plus 2 because the denominator is 1. So that's just a line, right? Y equals mx plus b. So this is really a straight line. It does have a y-intercept and an x-intercept, so you could find those like we've been finding if you want. But it's not going to have any asymptotes because it's not a rational function anymore. It's a line that's going to have a hole in it. So the hole is the one that I want to find. So the hole, where was this undefined? It was undefined at positive 2, right? Because 2 minus 2 would have given me 0. So my hole is at 2 comma something. What do I do with the 2 to find the something? Yeah, plug it into your new equation, right? So 2 plus 2 is 4. So I'm going to have a hole at 2 comma 4. If I want to find my y-intercept, I could, right? I could just plug in 0 for x. So if I plug in 0 for x, I get 2 over 1. I can find my x-intercept by setting my numerator equal to 0, the same way I normally would. So negative 2 would be my x-intercept. So if I plot these, it's going to form a line. So 0 comma 2 is my y-intercept. We know that it has a slope of up 1 over 1. So that hits my x-intercept. If I keep going, I would get to 2 comma 4 with a hole. So it's just a line that has a hole in it. So there's my x-intercept, my y-intercept. Up 1 over 1 is this line. And then there's my hole at 2 comma 4. So to me, this really isn't a rational function. It's a line that has a hole in it. Doesn't look like any of the other elbows that you've drawn. So if you cancel out your denominator, be on the lookout for maybe just a line to show up. And what would my domain and range be? So a line is usually all real numbers. So the only undefined x and y value are going to be right there at the hole. So x can never be positive 2 and y can never be positive 4. And if you graph it, I think you might see the hole. X squared minus 4 divided by x minus 2. Or let's see. I don't know if it's going to be big enough on here for you to see it. Yeah, I can't see that there's a hole in that line, but if I go to the table, there's an error at 2. So there is a hole. All right, the last one I wanted to set up for you, but then have you try the questions on your own is number 3. Actually, I don't really have to set this one up for you. We did an exploration in here about the parent function and the transformation rules. Do you remember that? So remember the parent function, which was just 1 over x? What can you tell me about the parent function? Anyone remember what the asymptotes were? Without going through all of the steps. Do you remember what this one looked like? Remember it had just a cross here and here of asymptotes, and then it went through 1, 1, and it went through -1, -1. So if that was the parent function, I could really just use transformation rules if I wanted to. So what would the transformation rule be? If it's x plus 3, what does that tell you to do? Left 3. So you can move your cross left 3, and then what does the -5 do? Just shifts the cross down 5. So your crossed asymptotes will just shift left 3, down 5, and then you can go 1 unit on either side of the cross. To me, that's easier than making it into a fraction, and I would just use transformation rules. So I don't know if I'd go through the steps of graphing it like this. It's not going to have a hole because I can't cancel anything. So I would just go ahead and draw the graph with transformation left 3 and down 5. I am going to do some simplifying rational expressions today, though, on the other page. But this isn't a good 1, 2, 3. One year I skipped doing the parent function, so we just did it with our rules, but we actually did the transformation to this time. So we've got a vertical at x equals -3 and a horizontal at y equals -5. And then if you just go 1, 1 and -1, there you'd be. So we graphed it a little bit differently because we didn't actually find our x-intercepts or our y-intercept. We could, but to me that graph is just as good. So our domain would be x cannot be -3 and y cannot be -5. So domain and range would still just be your asymptotes. All right, you try number 4 on your own. See if you can factor it, cancel it, and graph it. And I can walk around if you need some help, but I don't know if I put this on this video, but here were the answers to number 4. How can I write a rational function that has a domain that x can never be 7? Give me an example. What factor would have to be in the denominator so that when you plug in 7, it gives you 0? You got to have anything that has x minus 7 in the denominator. You could put x plus 3 in the numerator if you wanted to. You could put 1 over x minus 7. You could put 1 over x squared minus 49 because that would factor into x minus 7 and x plus 7. Oh, I guess then it would have another domain restriction though, so that's not a good example. You only want to have the domain excluding 7, so you don't want any other factors in the denominator with it. So see if you can go through, think about your other rules, right? How do I do my horizontal asymptote for number 6? How do I create a slant asymptote and a hole, right? A hole, something has to cancel with something else to create a hole. So see if you can problem solve for a couple minutes and come up with, you're building an equation. So think about, how do you have a slant asymptote? Where does the power have to be bigger? How do you have a horizontal asymptote at 5? Where does the power have to be? So you're using rules 3, 4, and 5 to try to build some of these functions. So take a stab at it. So at least you've tried problem solving before we put up the answers. Because this is the notation, this is how they use domain and range in calculus. Kind of a step up from inequality notation. This is just saying why the range can go from -infinity to +infinity, but it's excluding 2. So union means or. Y is either in this interval or Y is in this interval. So it's just saying Y is everything except 2. So that's going to affect the horizontal asymptote. I need a horizontal asymptote at 2. So that's going to happen when I strip the coefficients of x, right? The numerator and denominator are going to be equal in power, and I'm going to strip the coefficients of x. So make up anything that when you strip it, you get 2. So you could do like y equals 8x plus 5 over 4x minus 1, right? When I strip the 8/4, I get 2. They both would have to be linear functions, or they both would have to be quadratic functions. So you could have like y equals 2x squared plus 5x plus 8 over, it has to be a quadratic, so I could say like x squared minus 9. So 2x squared over 1x squared gives me 2. Make sure, obviously, that things aren't going to cancel and factor and cancel, but that doesn't factor. So does that kind of make sense? So you're stripping those coefficients and getting a ratio of 2. So number 7, look ahead. A slant asymptote, that's just going to affect the power, right? The numerator needs to be a higher power so I can do division. Oh, a vertical asymptote. I can build that in the denominator. If it's at x equals 4, I want x minus 4 in my denominator, so that when I plug in 4, it's undefined. They want a whole. So a whole is when you cancel a factor out. If the whole is at -1, I want x plus 1 as my factors that are going to cancel with each other, right? So then at -1, this would have been undefined. So y equals, I need the power of the numerator to be 1 greater than the power of the denominator, so that when I divide, I get a linear asymptote. This is currently a quadratic. This is currently only a linear function. So you could like add x squared if you wanted to. That would make it a cubic function over a quadratic function, something like that. Or you could put 3, x plus 5, x plus 2, x plus 1 over x minus 4, x plus 1. Because then the x plus 1's cancel, and then I still have a quadratic over a linear function. So there's many correct answers as long as your powers are correct. So to me, those are really challenging questions. Try number 8. If you haven't had a chance yet, now maybe if you understand how to build a whole or how to build an asymptote, maybe that'll make more sense. And then we should have time to just do maybe number 1 on the next page, simplifying a rational expression that's not just a transformation rule. That's not pausing. You have to have these matching factors of x plus 3. You have to have a factor of x plus 1 in the denominator. Somehow when you strip the coefficients, you have to get 5. So you could have 10 over 2. And then you have to have another power of x. You could square the x plus 3. You could write x plus 4. As long as when you strip the coefficients, you get 5, and you have to have a quadratic over a quadratic, or a cubic over a cubic. Does that kind of make sense? These are tough. 5 through 8 is really some critical thinking about how to build the function backwards using your rules. So you really understand your rules if you can build these backwards. And I think, let me just see. So like number 7 on the team test, it has you build a rational function that ends up looking like this with some holes. And I think on the review sheet, there's another one like this too. Maybe not. Nope, the review sheet's just some practice. So analyze, guided practice on page 210. So we're going to look at this tomorrow. So building a rational function that has a whole and some vertical asymptote. So we will get some more practice with that tomorrow after the quiz. So here's the last one I wanted to try, unless we have time to do 1 and 2. So this is page 208. This is a rational function that's not one of those simple transformations. It would have had to say 1 over x plus 2 for it to be a transformation. This says x over x plus 2. In order to use your note card, you need to have one fraction to work from. So you need to use your simplifying skills that you should have done in trig. And if you have 2 fractions, you can add them together if they have a common denominator. Does that sound familiar? That maybe you simplified rational expressions? So my common denominator, if this is 4 over 1 right now, my common denominator is going to be x plus 2. So I'm going to multiply by x plus 2 over x plus 2 because that's like multiplying by 1. Does that sound familiar about combining 2 fractions together? If not, we're going to practice it a couple times. So your denominator, like let's just talk about fractions. If you had 8/3 plus 5/3, you would have 13 thirds, right? You add together your 8 plus your 5, and you keep your common denominator the same, right? 8 apples plus 5 apples is 13 apples, or 13 thirds. So over here, I'm adding 2 fractions together, so the denominator stays the same, x plus 2. The numerator adds together all the stuff that's in the numerator. So I distribute the 4, so I really have 4x plus 8 right here. 4x plus 8. and I have this additional x from the first numerator, so I really have 5x plus 8. So 5x plus 8 over x plus 2. Now this is set up so I can do my note card. I've got my numerator, I've got my denominator, and I can do all the steps. So I'll let you try doing all the steps in a minute. There's nothing that's going to cancel, so this doesn't have a hole. So let's see how we would simplify example 2 together. I cannot do my rules for rational functions right now because they're two separate things. So if this is currently 2x over 1, and this is currently 9 over x, what's my common denominator going to be? X. So I have to multiply this second fraction by x over x so that I get x in the denominator of each fraction. This is a little bit higher order thinking because I know fractions tend to freak people out a little bit. So my denominator is just x now. And what's my numerator? This 9 plus 2x squared. 9 plus 2x squared. So to me, that's like the one-up step. Like you're advanced, you've got your note card to do the 4 steps, but you might have to factor and cancel first. You might have to simplify a little bit first. And the test won't be loaded with these. These will not be on tomorrow's quiz, but we should be able to combine 2 fractions with a common denominator, maybe once on the test. So I'd like you to take the last maybe 5 or 8 minutes, at least do example 1 out as a graph. And then if we need to start with this next time to finish example 2, we can. Here. So here are the answers to 208. This was nothing. I was just showing how to. And then here's the answer to the bottom of 208.